A meteorite large enough to scorch and melt such a vast area of ground had to be big. And even if the crater's been eroded, there is still one place from where it should be possible to spot it.
Booster ignition and liftoff.
Farouk Elbaz is head of the lab in Boston that interprets pictures of Earth taken by orbiting satellites. He's been looking at pictures from space since the 1960s. Back then, only about 20 impact craters had been found.
With the advent of satellite images from space and the fact that we're going to be recognizing all of these circular features, we now have at least 200 that are proven or semi-proven impact craters.
One reason there are not more known impact craters on Earth is that some are so big they can only be spotted from space. And the older they are, the harder they are to find.
It is really important to look for a crater that has the right age for the formation of this class, because if we say that this class is of meteorite origin, which is most likely, then there should be a crater of that age that would have formed that glass. So these things must come together.
To help Elbaz in his search, he needs to know the age when the glass was formed. And it is possible to pinpoint the age. One technique is based on the rate at which the element uranium decays. It leaves tiny scratch marks on the glass, which, when counted, gives its age. This method produced a date for the desert glass. It was formed nearly 30 million years ago. It was an important result. But could they find a 30-million-year-old crater?
It's not really a problem in this part of the world to locate a 20 to 30 million year old structure, because no matter what the erosive processes were like, you still have in the subsurface the imprint of that impact. For instance, we have the structure here in Chad that has been dated to be older than 200 million years, which means that anything that is 20 or 30 million years would certainly be visible.
So Elbaz and his team have been searching the area looking for suitable candidates.
We have some craters in here, a tiny one in here, larger craters in south of here, but nothing in that zone that can be called an impact crater. So here is the Great Sand Sea and the dunes going down southward this way. And the silica glass region is right here, and it is a little too far from any of the impact craters that we have formed around. So we conclude from that we have not really found the smoking gun for the silica glass in the Western Desert in Egypt.
Whilst studying the satellite images, Elbaz spotted a circular formation that he thinks needs closer inspection. But the formation is 100 kilometers from the main concentration of glass, and other scientists remain doubtful that this could be the source. Yet, if there's no crater, then some enormously powerful cosmic event happened here nearly 30 million years ago, and left little more than glass behind. It's this seemingly impossible puzzle which could be solved by the new theory Mark Boslow is developing. The theory starts with an observation made 60 years ago in the desert of New Mexico. The Trinity site is where the world's first atomic bomb was detonated. Sergeant Ben Benjamin was part of the official photographic team. He was just 22. Cameras were set up at several locations. Ben Benjamin was in a concrete bunker 6 miles from the blast site. For all of them, it was an awesome, almost surreal experience. At 5:29 on the morning of July the 16th, 1945, the bomb was exploded.
We had a PA system They were counting down in seconds, and when it came to -10, I switched on all 4 cameras, and it went off, and it was incredibly bright. It turned out to be 20-some times the brightness of noonday sun. And my God, it was the most amazing thing that I had ever seen in my life, and I'll never forget it.
A mushroom cloud exploded into sky with the force of 20,000 tons of TNT. A week after the explosion, Benjamin was allowed into Ground Zero. What he saw was startling.
And of course the whole tower that the device was on, all that steel, tons and tons of steel, was absolutely vaporized.
And a bigger surprise was what had happened to the ground.
Oh, it was covered with green glass, the melted sand here. All the sand had melted on the top, the first quarter inch or so. This green glass was covering the whole entire area, and it was cracked, and but one could walk on it, and you'd crunch. You'd be walking like on a field of maybe ice.
The sand was transformed into a thin layer of glass, covering an area nearly 600 meters across. Could something similar have happened in the Egyptian desert, but on an even bigger scale? The area where the desert glass is found is huge.
From here we go down another about 10 or 15 kilometers and we find still some glass. And we go up about another 30 kilometers even and we find glass. We're very close to the center of the area where we have the glass around here.
If such a large area of glass was formed as a result of an explosion, it must have had the power of many thousands of atomic blasts. A natural explosion of that magnitude was completely unheard of. No one had any idea of how such a devastating blast could have been produced. The only clue came from a place called Tunguska in the forests of Siberia. In 1927, a Russian scientific expedition visited Tunguska to investigate a massive explosion. The explosion had actually occurred in 1908, but Tunguska is so remote it was nearly 20 years before they saw the scale of the devastation. They were astounded. More than 80 million trees had been destroyed. The scientists were puzzled. What could have caused such an enormous explosion? Their first thought was that it was a meteorite, but they couldn't find a crater. They returned to their laboratory and carried out a series of slightly odd experiments. No one had seen anything like this before, and Tunguska became a scientific mystery. Since then, scientists have had many theories, but it's now assumed that an extraterrestrial object somehow exploded about 8 kilometers up in the atmosphere. This aerial burst was equivalent to about 20 million tons of TNT. Perhaps a similar aerial burst, but even bigger, happened in Egypt. What happened there was hot enough to melt the ground over thousands of square kilometers. This is where Boslow's expertise comes into the story. At the Sandia Labs in New Mexico, he's developing a computer model to see if the airburst theory can be right. An event in 1994 was the turning point, the impact of the comet Shoemaker-Levy with the planet Jupiter. When the comet went into orbit around Jupiter, it broke up into over 20 fragments. Then, one by one, these fragments hurtled down into the Jovian atmosphere. Nothing similar had ever been witnessed.
I think that the impact on Jupiter was really one of the most exciting things to ever happen in the history of science.
Boslow's speciality is the physics of large impacts, and for that he uses computer simulations. For Boslow, the Shoemaker-Levy comet was to be the biggest, most exciting experiment imaginable.
This was a real opportunity to see something that we couldn't see in the laboratory, something of a scale, of a magnitude way beyond anything imaginable, beyond our wildest dreams.
Boslow's team had been developing a new theory which predicted that the impact would produce a massive fireball.
This is a sequence of snapshots from our simulations. The top image shows this incandescent fireball rising over Jupiter's horizon to be seen from Earth. And in subsequent frames, you see this fireball growing and cooling, but growing into this enormous plume to very high altitudes. It just gets huge.
When the fragments of Shoemaker-Levy smashed into Jupiter, the pictures from the Hubble telescope were just as spectacular as the simulation predicted.
When we saw the Hubble Space Telescope images for the first time, we were so excited to see this spectacular plume rising over the horizon.
Their predictions were very close.